The last part of this chapter review asks us to use the useful part of this entire chapter, which is using the definition of derivative to find answers that we're going to need in the future. And if there's anything you want to make sure you understand, it's this part, where slope is the change in y over the change in x, which we used to write as having two coordinate points where we'd have x1 and y1, then we'd have another coordinate point, we call it x2 and y2, and we would find the slope between them to generalize what the slope at this last point might be. And it's not perfect, but as you bring points closer, maybe I make this my new x1, y1, you'll find that this slope is closer, and as I choose an even closer point, you'll find now that I'm really getting close to the right approximation, and as you guess, of course, by now know, if you bring these points infinitely close together, you will get an infinitely accurate answer. So what we're going to end up doing, instead of y2 minus y1 over x2 minus x1, is we're going to rewrite this as 2 points in space where this will be x and f of x. I wrote that horribly, and I'm just going to take a quick second here. X and f of x. And though we will bring them infinitely close together, let's say that we haven't yet, this does not have to be a new point name like x2. We can define this distance as h horizontally, so we'll say that this travels x plus h. That's the x value for this one. And the y value would be x plus h put into the function, so it's f of x plus h. Okay, so far so good. So y2 becomes f of x plus h, and y1 just becomes f of x. That's this guy here. And we're going to divide this, once you simplify x plus h minus x, you get h on the bottom. So here's our definition of derivative. That should be well in you by now. That should have been an annoying review for you if you're ADHD like me. But believe me, hammering it in over and over is going to make your brain work. That's just what the brain is. It sucks like that. Now, they give us something specific. They say find f prime of 2. So first let's find f prime, right? It's going to be x plus h plugged into the function, so that'll be x plus h cubed minus 2 x plus h minus x cubed minus 2x. And all this is going to be divided by h like that. And if we expand, remember Pascal's triangle here? I hope you do, because it tells us the coefficients so well, right? Here's row 3. So that's it right there. And then we're just going to expand our x cubes down and our x and our h's up. So we'll get 1 for our first exponent here, or first coefficient here, x cubed plus 3x squared. Notice I'm stepping it down, and then the h's will appear. Plus 3x, step down the exponent again, and step the h's up, and then 1 h cubed. Minus, we don't need the end of that parentheses yet, we can expand this part here, minus 2x, I think my PC is getting a little hot, minus 2h, minus x cubed, plus 2x. And all this is going to be divided by h, of course. So, favorite part, let's do some cancel. Negative x cubed and positive x cubed cancel. 2x cancels, negative 2x cancels. Who's left? Who you got? 3x squared h plus 3x h squared plus h cubed minus 2h. And all this is going to be divided by h. Let's cancel right now. That h goes, that h goes. This becomes an h squared. This becomes an h to the 1. This h goes away. What am I left with? 3x squared plus 3xh plus h squared minus 2. Now we remember that our points are going to come infinitely close together. And because we're not dividing by 0 anymore, which is the whole point of leaving it as an h instead of making it a 0, we can cross off the zeros. There's a 0, there's a 0, that's a nothingness. So our answer is going to be 3x squared minus 2 for f prime of x. That's the slope of our original function at any point. So they want f prime of 2, so we plug 2 in. We're going to get 3 2 squared, that's a squared, minus 2. 3 times 4 is 12, minus 2 is 10. So f prime of x at 2 is equal to 10. And that means whatever our graph, which they're going to want here, we can just do that now. I'm going to get this wrong, but by guesstimation. So there's a point here at 2, 4. I'm going to say that's 2 and that's 4. We're going to have something like this happening. Some kind of x cubed. I don't know exactly where the intercepts are. I'm not calculating it right now, but I do think it goes through the origin, maybe something like this. But we know that the slope here is 10. Okay, that's not the same as a slope here where it's like 0, right? So we only know the slope at this exact point. But that's all they want, right? They want you to graph the tangent line that barely touches this spot here. And we can do that because we have the slope. And they gave us the other stuff right here. They gave us the point. We know y equals 10x plus b. And we know y is 4. And we know x is 2. So that's 20. Subtract it over and you get b is negative 16. So the answer is going to be y equals 10x minus 16. You can bet the y-intercept for this comes down here to negative 16. That's the graph. That's the whole problem. That's what they want from you, okay? And typically, look at the problem. If you see illustrate, make that your part A. Just try to graph this before you even do math. Believe me, the picture is just better. Now let's come down to the next one that I thought was kind of tricky. This could be in a chapter review for you, so let's pay attention to this. Find a function and a number A such that this scary thing is equal to f prime of A. This is the kind of thing I feel like a student is likely to get stuck on because it takes me a second to think about what the heck they're actually asking. But remember something. F prime of A, since that's what they want, right? Let's just ignore the limit thing. Because you know you're dividing by 0. That's why we put in all this stupid notation. We want to pretend that we're not dividing by 0. But we do know that it would be f of A plus h minus f of A divided by h. So when I'm looking at this, I connect it to this. Okay, so it looks like our A is going to be equal to 2. Because that's right here. Are you able to see that, where I'm at with that? It's right here. Okay, and f of A is equal to 64. And you see this like to the 6th power here thing? I think that's your hint. Because 2 to the 6th is 64. So I think that the question here would say like f of x is equal to x to the 6th. Because if I want to calculate f prime of x, you would get x plus h to the 6th minus x to the 6th all divided by h. And the 64 matches that if we choose 2 for our value of x. And this gives me 2 plus h to the 6th. So it's not, I don't think, supposed to be as hard as it might actually be, because you're kind of working backwards conceptually. But if this hits for you at all, you're in good shape for now. And I wouldn't worry about it too far past that.